In this video, we're going to be finding the eigenvectors for the two eigenvalues that we found in the previous video. The eigenvalues are 3 and 10. Now, if you'll remember, we were able to simplify our eigenvalue problem to this matrix, and for a 2 by 2, that ends up being you're subtracting the eigenvalue along the diagonal. In this case, you've started with this matrix, and you've subtracted the eigenvalue along the diagonal. From here, we choose the first eigenvalue that we found, which was 3. I'm just going to write that here. Now we want to find the eigenvector for this. We can find the eigenvector by plugging this eigenvalue into this equation. And what that gives us is the following. Just by substituting this value into this matrix, when you simplify it, you end up with this. Now, if you remember, we're looking for values that give us an eigenvector. And we can take this equation and we can simplify it down into the linear set of equations, and that'll help us find the eigenvector. So if we assume that the elements we're looking for are x1 and x2, we can write this as this. Now at this point we need to choose one of the equations so that we can find the first eigenvector. And we can solve and we can choose a value for x1. Because we have a large number of solutions and the eigenvector can be any multiple, we just have to choose a number. Oftentimes you'll choose the number 1 because that will make your problem simple. So I'm going to take this equation and I'm going to move x2 over to the right hand side. And that's going to give me this. If you simplify it a bit more, you're going to have this. And now, at this point, I need to choose a value for x1. I'm going to say x1 is equal to 1. If I say x1 is equal to 1 and plug this equation in, I'm going to get 1 equals negative x2. That means that x2 is equal to negative 1. Now that we have x1 and x2, we have x, and this is a solution vector to this problem. We have this as x1, x2 equal to 1 and negative 1. This is an eigenvector. This is the eigenvector that's related to this eigenvalue. We have one more eigenvalue, and we can find the eigenvector for that too. We basically perform the exact same operation, but this time, in this matrix, we're going to choose lambda is equal to 10. So now we're going to have 6 minus lambda, 4, 3, 7 minus lambda. Substituting in 6 minus 10, 3, 4, 7 minus 10. This will give us the following matrix. And again, we can take this matrix and put it into a set of linear equations. We'll assume x1 and x2 is what we're interested in. This gives us the following. At this point, I need to choose one of these equations and simplify it down to find the eigenvector. I'm going to choose the top one. This gives us 3x2 is equal to 4x1. That's pretty easy. Now, I'm going to just simplify this a little bit more by moving the 4 over. So we have 3/4 x2 is equal to x1. And I'm going to say that x1 is equal to 1. And that means that when you plug that into there, you have x2, 3/4 x2 is equal to 1. So x2 is 4/3. This means that we have x1 and x2, so our solution vector x, formed of x1 and x2, is equal to 1 and 4/3. This vector is a solution vector for this problem, and is the second eigenvector. In the next video, I'll be showing you how to find to make sure that you found the correct eigenvalues and the correct eigenvectors.